hang on to mom for much longer than maybe they're supposed to. So the placenta here, placental mammals, this is going to last a lot longer. This is now moving into the realm of very long gestation. A lot of interesting stuff happening here between the placenta, the genes in the embryo or the fetus, and the genes in mom. It turns out that the genes in the fetus, half of which of course come from dad, are going to kind of try to make the biggest placenta they possibly can. Think of the placenta as almost being a parasitic organism, and therefore the fetus is also kind of the same way. As far as dad's genes go, his preference would be for that fetus to make as big of a placenta as possible so that baby could grow as big as it possibly can to have the best shot at survival. For mom, that may not be the case, because if that fetus steals too much from her, that may actually cut her life short by some period of time. So for her, the better strategy is, yeah, you want to go ahead and support this offspring now, but you don't want to sacrifice potential future reproductive output by doing so. So you've got, on one hand, dad's genes selecting for a bigger and bigger and bigger placenta, mom's genes sort of trying to rein in that tendency and eventually settling on some average size. So anyway, that's kind of a digression here. But most living mammals fit the placental model of development. Things like cetaceans, like our cute little dolphin here, but everything else from rodents to primates to cats and dog families to the weasel family and the bear family and all those kinds of things, they're all placental mammals. All right, as far as the primates, this is the group, this is a family of mammals. I'm sorry, again. Man. This is the order of mammals. The primates are an order, very definitely an order, that gave rise to our own species. Mammals started in treetops. They were an arboreal, which just means tree-dwelling type species. So a couple of things to kind of help with that. They've got very, very good grasping appendages. They have paws or hands with toes that are very flexible. They've got a lot of dexterity. They can grab things and hold on to things very well. Some of them even have a tail they can use to hold on to treetops or branches or things like that. So they're very good at holding on, which is a good thing if you want to be in the trees. You want to be able to not fall down. They also have binocular vision. So eyes kind of rotated to the front of the head, which allows them to see three-dimensionally. They can triangulate vision onto an object and get a very good sense for distance. Again, if I'm going to be moving from branch to branch, 50, 70, 100 feet up in a tree or more, I want to be able to see how far away that next branch is. I don't want to have to guess on how far away it is and maybe fall short. So grasping appendages, very, very good eyesight, allows them to judge distance as well as maybe capture prey they're looking for up in those trees as well. A lot of people think that binocular vision actually sort of happened first to allow them to pick out and find very small insects on trees. They need very acute vision to do that, and of course it becomes an advantage later on when they're moving very actively through the treetops as well. We're going to kind of move now into the human evolution aspect, the primates, and eventually the early human evolution. So we'll kind of make that sort of optional. I'm going to go ahead and do it, but you're not required to look at the rest of this or necessarily even be too responsible for it on the next quiz or test. I might throw one question at you, but it's not going to be a huge chunk of this chapter. I don't want to bias things too much toward humans. So 40 million years ago, we're now post-dinosaur extinction. We've got the very, very early primates, again, primates being an order, like the rodents are an order, and so forth. We can now look at two groups of primates. We've got the prosimians, which are things like this very relatively primitive but very, very cute little prosimian animal here. Lemurs are prosimians. Lorises and tarsiers are also prosimians. Very, very big eyes, almost cartoonishly big eyes, which we can look at here on this little guy here. Very bendy toes, very sharp nails for sort of anchoring themselves in the treetops. Very good eyesight. Very big eyes, kind of hints at sort of a nocturnal lifestyle. Not really a ton of these around anymore. Lemurs are endemic to Madagascar. Lorises and tarsiers live in other tropical parts of the world. We don't really find these things around here too much, although maybe it'd be kind of cool if we did. They're more of an old world type species. And then we also have the anthropoids. Okay, so a couple of terms here. These all look fairly similar, at least to me. So anthropoids. Anthro refers to human. Anthropology is a study of human culture or something similar. Anthropoids are human-like primates. So who are they? All right, we've got things like gibbons, which are kind of the least similar to humans, but they're still considered to be anthropoids. They are things like the orangutans, which are kind of the next most similar to humans. They are things like the gorillas, which are even more similar to humans. And then we have eventually the chimps and the bonobos, which are most human-like. So anthropoids are the group of primates, just a sort of convenient grouping of primates based on at least a superficial appearance to humans. All right, so that's anthropoids. Hominoids refer to our ancestors. Right? Hominoids are other species which are precursors to our own species, precursors to our own family. They're sort of the transitional form between anthropoid primates and hominid primates, which are our own family. Hominids refer to any kind of primate within the family Hominidae. Hominidae is our own family. It's the human family. So we're Homo sapiens. There has been Homo erectus. There has been Homo habilis. There has been Homo floresiensis. There's several other species of humans within this family. Of course, we're the only modern extant species of hominids, but it's sort of the most specific grouping of these three terms. Kind of look at these three terms as being most general to most specific. So anthropoids are all human-like primates. Hominoids are all more human-like primates. And then hominids are the things in our own group, our own family. All right, so anthropoids, first of all, are exactly this big, apparently. Cute little guy there. I know a bunch of you guys just said, "Aw." I thought it, don't worry. The reason why these anthropoids are set apart from the other groups is that these are, they're diurnal. They've got very smaller eyes, but still very, very acute vision. They don't have a tail, right? So a lot of the other things that we've seen, the lemurs and so forth, lemurs are kind of famous for having a very long tail. The anthropoids don't have a tail, so if you look at things like an orangutan or a gorilla or a chimp or a bonobo or certainly us, there is no external tail, so we have that as well. Brain size gets much, much bigger. The classic hallmark of the humans as a species is an increase in brain size from all the way up through the family Hominidae to our own species, going from maybe 500 or 600 cubic centimeters all the way up to 1,200 or 14 cubic centimeters. Very, very large brains as we sort of evolve. Anthropoids are also gregarious, which means they're social. Gregarious means they like to be in groups. Lots of social interactions, lots of dominance things, lots of even battles between groups, as you might see in us, for example, but also in things like chimps. They will go to war with each other. They're their own little groups or families of chimps will actually go to war and fight each other and kill each other in the process. The young are very much precocial. Okay, so precocial is a term that refers to an animal that is born very, very, very helpless. Right? Precocial young are completely reliant on the parents for help. Think about a human infant. Like, take a human infant, like, not literally, this is terrible to say, but if you imagine a human infant on its own in the jungle somewhere, it's not going to do real well. It needs mom or dad or both there to help take care of it for kind of a long time. Even a human child, 4, 5, 6 years old, wouldn't do much better in the jungle by itself. So you got to have parental care. All right. The opposite is to have something like altricial young. So altricial young are born very, very advanced. Think about a deer that's born, a fawn that's born, or horses when they're born, or birds that are born more or less able to fly pretty early on. They're born with feathers. They're born with eyes open, that kind of a thing. Those are altricial. Right? They're able to take care of themselves pretty quickly after birth. Anthropoids are most definitely not that way. They need a lot of parental care. They need a lot of help taking care of the offspring, raising the offspring, teaching the offspring in some cases, allowing that big brain to grow and get able to learn and pick up things from the environment and eventually take care of itself. So that's a very, very a big hallmark of human evolution here. All right. The New World monkeys, about 30 million years ago, so remember we started at 40 million years ago, about 30 million years ago there was this migration of what we call New World monkeys to South America. Monkeys in general are going to tend to have a tail for the most part, between a monkey and an ape. Kind of the rule of thumb is that apes don't have tails and monkeys do. Old world monkeys are things like baboons and other things. This isn't a baboon over here, but other things as well that are kind of similar. And then the hominoids, especially, moving into our own much, much more human-like things are gorillas, very human-like. If you've ever watched a gorilla on Animal Planet or been to a zoo and watched gorillas or chimps or orangutans, they act like people. I don't care what anybody says. If you go and watch how these things interact with each other, how they watch us, if they can see us at the zoo, very much human-like. And then, of course, humans who apparently go into the woods in very strange-looking white dresses and barefoot for some reason. I'm not sure why that picture was taken, but okay. They're certainly in the hominoid category as well. All right, so New World monkeys are all arboreal. They very rarely will come down to the ground. They use those tails, those prehensile grasping tails, not only for balance, but also to hold on to things while they feed or move through the treetops. Old world monkeys and then our hominids, our own family, remained in Africa, stayed behind, and eventually gave rise to our own species. And again, the old world monkeys don't have tails of any kind. The apes certainly don't as well either. All right, so the hominoids. Right, now we're moving into the more human-like groups of our own species, all right, or cousins to our own species, I guess is a better way of saying it. Up here on this picture, this is a very, very nice picture from your book, showing you the relationship between the different groups of primates, again, within our own order. Lemurs and lorises, the sort of prosimian type groups over here, along with the tarsiers. We've got the New World monkeys splitting off next. These are all the Old World monkeys out here. So Old World monkeys like baboons and so forth. And then moving into our hominoids, which are your gibbons and orangs and gorillas and chimps and bonobos and humans. They're hominids, Homo erectus, other species, and things like that. So very, very big brains. Certainly no tail. This group over here, again, the hominoids is a sort of one of those paraphyletic kinds of things because it is very likely some of these may even deserve to be in our own family. In some cases, depending on how you classify these things, bonobos and chimps in particular, people have argued to some degree of success that maybe they should actually be in the hominidae as well, in the human family, because they are so similar to us, not only behaviorally and physically, but also even socially. A lot of people, of course, don't like that idea, but if you sort of look at things from an objective perspective, they're certainly very, very similar to us in a lot of ways. So the hominids, again, are humans. This is the lineage which eventually made its way to us. So we've got the gibbons splitting off, we've got the orangs splitting off, we've got the gorillas splitting off, and then we have the chimps and hominids, kind of two almost like sister groups splitting off last, and very recently having chimps and bonobos splitting off from us in our own human lineage. All right, so moving into the hominid type lineage. Going from old world monkeys to hominids. Very likely what happened was there was a transition from an arboreal kind of lifestyle to more of a terrestrial on the ground kind of a lifestyle. What initially happened, if you sort of look at other types of apes or old world monkeys, things like gorillas or orangs, they do what's called knuckle walking. They walk on their hind legs, but they still kind of support themselves on their forelimbs as they walk periodically. Right? They're walking on all fours at least part of the time. Humans, at least most of us, don't do that. We're more of a bipedal species. We walk around primarily on our hind legs. So what people have wondered for a long time is why would this transition happen? Why is it that these old world monkeys would go from being primarily arboreal to being primarily walking around on two legs on the ground? And the reason for that, we think, is that in Africa, during this time where our own lineage evolved, in Africa, the climate changed. And the rest of the world too, but the climate change in Africa became much drier and much hotter. So a lot of trees began to die off. What used to be rainforest in Africa became savannas. Not really a desert, but certainly a much drier habitat, a lot more grassland, a lot fewer trees. All of a sudden becoming arboreal became very difficult. So species were sort of forced to move on to the ground and walk around on the ground. Now, if you're walking around on the ground in tall grass, there's other stuff out there, right? There are things like lions and things like that out there, predators out there. So if you can stand up and walk on your back legs, that's going to allow you to see further in the distance. Maybe watch out for the lion hiding in the grass over yonder. Yeah, I said over yonder. Deal with it. And be able to see further in the distance. Maybe watch out for predators. It also allows you to carry stuff. Right? You can walk on your hind legs. You can carry food in your arms. You can carry your baby in your arms. You can carry lots of stuff, eventually tools in your arms as you walk around. So that becomes a very big benefit as well. So moving onto the ground selects for bipedal locomotion, and it frees up the forelimbs to do other kinds of things. As a result, we see a lot of the uniquely human kinds of things resulting. Our vertebral column, which becomes curved as we develop. When you're born, your spinal cord or your backbone is completely straight. Once you start to walk upright as a kid, as a child, your backbone is going to get a curvature to it, which of course can be problematic if it becomes too severe. We also have the fact that our spinal cord comes out of essentially the base of our skull, which can create some problems because that skull is very heavy. Especially if you have a giant head like I do. It's very heavy and it can cause a lot of neck and back problems later on in life if you're not careful. A lot of foot problems and back problems happen because of the fact that our body is entire weight supported by only the lower limbs. Think about the surface area or the area of your feet. The area of your body you actually stand on is not that big. And it's supporting 100, 200 pounds, maybe more. That's a lot of weight to be pushing down on those feet, on those legs, and on the knees and the ankles and everything else. There's a lot of things that happen in humans because of the fact that we walk upright. Not good things, medical conditions, um, all kinds of foot problems that happen. Hemorrhoids actually happen in humans. They happen in no other species, so I guess we're lucky there. The fact that our circulation in that part of the body is fairly constricted from our posture can sometimes lead to circulation problems, which can then lead to hemorrhoids. So lots of uniquely human things which aren't necessarily a good thing. Varicose veins is another one. No other species gets varicose veins. They happen because the veins in your legs are there's a lot of force needed to get the blood from your feet back up to your heart, and so you start to get a bit of a degeneration of the veins in your legs. So the very early hominids here, our own genus of Homo is about 3 or 7 species, depending on again who you talk to. Australopithecus is one of the very old ones. There are about 7 species of this. They're the ancestral group, or at least a parallel group that's older than ours, of about 7 species. Heavy-bodied, smaller body size, definitely a smaller skull size, so that means a smaller brain. Much more primitive kinds of traits. Again, these are all hominids here. These are all hominids, which means in the hominidae. If you talk about the Canidae, which is the dog family, you talk about canids. If you talk about the Felidae, which are the cats, you talk about felids, right? So in the hominidae, in the human family, we talk about hominids. There are several other traits in other lineages that are different, but the one consistency is that in all these different groups of hominids, we all walk upright. Walking upright is probably the first uniquely human thing that eventually led us to where we are today. Just the ability to walk on our back legs is what eventually led to increases in brain size, in language, in tool making, and all those other kinds of things, which people have argued for a long time are what make us us. Another really great picture from your book showing you the transition, the timeline of human evolution from 7 million years ago. Very, very old types of species. Australopithecus over here, Australopithecus afarensis, which actually shows up 4 to about 3 million years ago. Look at the difference in this skull compared to our skull over here, right? Very, very heavy jaw, very, very small cranium. Compare that to us, relatively small jaw, very, very big cranium, almost like a dome over here for that very large brain. That's kind of the progression that happens all the way through here. We move into Homo habilis, which is one of the very old ancestors of the genus Homo. We have Homo floresiensis, which is another one. We have Homo erectus, which is the one that very likely transitioned into us. You see the gap here between Homo sapiens and the gap between Homo erectus. They pretty much overlap here. Homo floresiensis is an interesting one. This one actually happened. It was found on an island. It's been found nowhere else in the world. Very, very tiny species. Look at the skull here. It's almost like a very miniature human over here. And so we see this a lot on islands. Island animals, island species tend to be smaller than the same species on the mainland because there isn't as much resource on the islands. They're smaller. So on these islands, you had Homo floresiensis, which is a very small statured human, living in parallel with other species of things like elephants, which are also very tiny. They're like, horse or even large dog-sized elephants that these people would hunt. So kind of a cool little thing happening out there on an island, little microcosm out there on the island of what was going on here with our own evolution. You got Neanderthals over here. Everybody's heard of Neanderthals. You've seen probably cartoons, Gary Larson cartoons or Far Side cartoons with Neanderthals. Actually not as primitive as what a lot of people sort of thought or picture. They're actually in many ways very advanced. Neanderthals actually were the first in our lineage to bury their dead. They had ceremonial ritual. We found actually places where Neanderthals have been buried. They're buried with stuff from presumably their life or from their loved ones. Very strong culture, very social type of, again, this is a species. This is not Homo sapiens. It's a species of the Homo genus here. So eventually, of course, moving into our own species up top there. So Australopithecus is again the most primitive, and so we found skulls of these things. Again, walking upright, found in Africa, which is pretty much accepted to be the main source of the origin of our species. On average, we estimate them to be about 18 kilograms, which is maybe 45 pounds, somewhere in that neighborhood. Only about a meter tall, so at most, 3 feet or so tall. They definitely have hominid dentition. They were definitely omnivores. They've got incisors and canines and premolars and molars. But as far as brain size, they probably were about the same as an ape. Right? You compare the cranium capacity, the volume of an Australopithecine to that of an ape, and they are pretty much the same thing. What the posture shows, what the proportions of the bones and the legs and the arms shows, though, is that they did walk upright. So again, we have definitely a transition here to bipedalism. Again, this is the transition that happens. We think that this happened about 4 million years ago, and we know without too much doubt that there was a relatively big climate change about 4 million years ago. So as the climate dries out, as the climate gets warmer, and as those jungles in Africa become savannas, we start seeing bipedalism almost immediately in the fossil record. The brain expansion that we talk about, the increase in cranium capacity, didn't happen until about 2 million years ago. So there's a bit of a delay between walking upright and eventually seeing a larger brain of about 2 million years, which is kind of a long time. Most people think now the bipedalism is sort of a combination of living in a savanna, watching out for danger, carrying tools, carrying young, carrying food, fighting with other individuals. All those things can happen if you allow your forelimbs to be freed up by walking only on your hind limbs. All right. So the first humans start showing up about 2 million years ago. Australopithecus afarensis happened about 2 million years ago. We know of things like Lucy, right? That's kind of a famous one. Lucy is kind of the famous Australopithecine here in Africa. The very early ones, sort of after Australopithecus, we get into things called Homo habilis, right? So the Australopithecines end about 2 million years ago, and the genus Homo picks up at around the same time with things like Homo habilis and Lucy. The main difference here, the size is about the same, the bone structure is about the same, but the main change here is that all of a sudden the brain starts getting bigger, and that's kind of a big change. I talked about Homo floresiensis here a second ago, living on islands. Flores is the island out in the Indonesian sort of island, ocean part of the world, sorry. These go back about 15,000 years, which is not very long ago. Humans, Homo sapiens, have been around for about 400,000 years or so as a species, maybe a little bit less than that, but a few 100,000 years. This species dates back about 15,000 years ago. So what we think happened was there was this population of humans on this island where they remained for a long time, and they actually were there long enough that they began to change, physically at least, to a much smaller statured individual. This picture here kind of shows you on the bottom here, comparing the size of sort of a depiction of a human, Homo sapiens, versus a Homo floresiensis. Much, much smaller, maybe half the height, maybe a little bit more of an average-sized human. It's thought they actually sort of were predators of this very tiny elephant, and skeletons of that have been found as well. So we have little miniature people hunting little miniature elephants, which is kind of bizarre, but still kind of fun in a way. I don't know. It's happening out there on the islands. And as I mentioned before, this is a very common thing. Everything from rodents to deer to birds will be a smaller body size on islands than they are on the mainland because of the resource base there to support them. We think this is probably more of a divergence of Homo erectus than it was Homo sapiens, just based on some other features like relative cranium size. Obviously, the cranium was smaller because the species was smaller, but the body size was smaller as well. So in this case, you kind of have to look at proportion of volume of brain case to size of body, and in that proportion looks more like a Homo erectus than it does a Homo sapiens. So modern humans start showing up maybe around 600,000 years ago, very likely coexisting with a couple of other species, right? So we've got Homo heidelbergensis, which is the oldest one, which is around parallel to Homo erectus. So erectus was around before this time. Heidelbergensis probably coexisted with them. They were around at the same time. They were contemporaries of Homo erectus. Eventually, Homo neanderthalensis comes along, which is shorter and stockier, very muscular, probably very athletic seeming. And then eventually Homo sapiens, which is our own group, and we're not at all egotistical because Homo sapiens means actually literally wise man, which seems a little bit of stroking our own egos there a little bit. But Homo sapiens is called wise man because the cranium size is the biggest. Not necessarily intelligence, but the size of the brain case is the biggest of the three, so we get our name to be wise man, I guess. Other people would lump all three of these into the same category, the same species. Others split them off into three species, so that's probably pretty arbitrary, actually. Neanderthalensis, again, this group, this species, has been sort of made fun of a lot in on TV and in movies and in Far Side cartoons and whatnot, but they actually were a very advanced group. There is some sign that they actually had some idea of symbolic thinking. They would actually do cave paintings, for example, which sort of is a very high level of thinking. To have a species that can take inanimate objects and arrange them into depictions of living things is a very relatively high level of thought. Like I talked about before, they took care of when they were sick or injured, they would take care of each other. They buried their dead. They had ceremonies. We found evidence of ritualistic burials of Neanderthals in various places in the world. So they were actually relatively advanced, much more so than some of the other human ancestral type species. The mystery here is where they went. Because what happened was about 34,000 years ago, all of a sudden there were no more Neanderthals. Some people think that maybe it was because they were actually killed off by contemporary humans. Cro-Magnon refers to Homo sapiens that was around about 34,000 years ago. This is the time period of humans. We know, for example, that they were around at the same time. We know that Cro-Magnons had a bit more complexity, were a little bit more advanced. They made very elaborate cave paintings. They had language capabilities. We think they were more advanced in some ways than the Neanderthals were. We think very likely a combination of two things happened, which eventually sort of pushed Neanderthals off. There was probably some degree of fighting between the two groups, and Cro-Magnon very likely had some relatively advanced weapons at the time, so that gave them a kind of a leg up on their Neanderthal contemporaries. They very likely also potentially hybridized with some Neanderthals as well. It says the two species did not interbreed, but there's also evidence now, more recently, to support the fact that maybe they did. Maybe there was some interbreeding between the two groups. You might think that's kind of odd for these two groups that are at war, but then remember, more modern situations when people go to war, they don't always fight. Sometimes they end up falling in love and getting married and those kinds of things as well. So that apparently happened here during this period of time with Cro-Magnon and also Neanderthals. Homo sapiens is the only modern hominid left. Some of our own features here. Obviously, relatively large brain size. We can make and use tools. Conceptual thought. We can do math and these kinds of things, which, as far as we know, is not something that most other animals can do. Symbolic language, right? So we can depict verbally what's going on in our minds or in the actual world around us, which is something which is unique to our species as well. The thing about humans, and so this has been a subject of some debate, is whether or not we are still at the mercy of natural selection and evolution. I would, for one, very strongly argue that we are. We have seen evolutionary change in humans in recent years, even the past few hundred years or a few thousand years. Things as trivial seeming as reduction in wisdom teeth, right? So it's much more common now to see people born without wisdom teeth than it was maybe 1,000 years ago. And so if you imagine 1,000 years ago, if you were born with the ability to produce wisdom teeth so that later on in life you actually had wisdom teeth, if they became impacted, if you had a problem, if there was an infection or some other difficulty, you didn't have modern dentistry to help you out there. That you had, maybe at best a guy with a hammer and a chisel to knock those things out of there. That by itself was very risky. So you might imagine that not having wisdom teeth a couple thousand years ago might have been an advantage. And in fact, as we go through time, there's actually documented evidence that people are having fewer wisdom teeth than what they did even a couple thousand years ago. It's not uncommon at all for me to, when I do this lecture in a classroom, to ask people how many people didn't have any wisdom teeth. Usually there's a couple of hands. People that only had one wisdom tooth, I'm one of those. I only had one wisdom tooth myself, and it really didn't become a problem, but the other three just never developed. So we still are at the mercy of natural selection. We're not outside of that. But we can also modify our environment more than any other species in the history of life on Earth. And that can be a good thing. Don't get me wrong, that's a good thing, but it can also be a very negative thing as well. Because we have the ability to change our environment, we may be somewhat outside the bounds of natural selection to a degree. All right, so that's one of the hallmarks of our own species, is that we can change the world rather than having the world change us. At least so far in our history, that's been the case in large part. One other thing I wanted to talk about here, because this sometimes comes up, this surprised me the first time I had this pop up in a classroom setting. I had a student one time ask me in a class, this was several years ago now, if human species could still interbreed now today. I was talking about Neanderthals, I was talking about Cro-Magnon, talking about them hybridizing and making different species, and I had a student ask me if the human species around today could actually breed together. And I was kind of confused at first, because I thought, well, we just talked about there only being one species of Homo sapiens. There's only one left. And so this person said, well, I'm talking about, people from Africa or people from Asia or people from North America. And so what I realized was this person was actually talking about races of people. Right? So it took me off guard, and it kind of it bothered me for a few seconds, but then I thought, okay, this is probably something I should talk about because maybe this idea is out there. No, there is only one species of humans, and species are defined as groups of organisms that can make viable, fertile offspring with each other, and pretty much all humans can do that with any other humans. There is no barrier to breeding in the human species, so there is only one species. The different races that are talked about is more of an arbitrary physical difference between organisms. It's almost the this is going to sound really bad, but it's almost the equivalent of breeds of dog, right? Breeds of dogs can breed together. They're not separate species. You can have a German Shepherd breeding with a Golden Retriever. That happens. They'll make perfectly viable and healthy offspring. So races of people is just a visual outward difference. It's absolutely meaningless when it comes to talking about one species or multiple species, or whether or not different groups can breed together. Because there is so much gene flow in our own species, because there's so much connectivity of human populations with other populations, it is very unlikely we'll ever get to have separate species of humans, because there's no barrier to gene flow. There's no population of humans that's never reached and is being allowed to evolve and change on its own, untouched or unreached by genes from other populations. So if you look at sort of genetic similarity versus skin pigmentation, maps like this, yeah, there are trends in human appearance throughout the world. If you live along the equator, like we've talked about before, or you've heard about before, you've got darker skin than you do if you live in the North Pole. But those genetic differences are very, very slight. They're genetic differences of one or two things. Overall, we are still the same species. So I just wanted to address that and sort of get that idea out of here, that there's somehow different species of humans. We are one species, and very likely will be one species continuously, unless we get some population of humans isolated at the bottom of the Antarctic Ocean or something breeding. They're probably going to be pretty disconnected from the rest of the humans that way. But in all likelihood, it's probably not going to happen that we'll split up into different species. So that's not really too valid of a point either. So, all right, well, that's the end of this lecture. I know I've rambled on for kind of a long time, so I'm going to go ahead and wrap this up. I hope it's been somewhat useful. If you have any questions at all, please do not hesitate to drop me an email or call me or speak to me during office hours, after class, during class, before class, whatever. Just let me know if you had trouble with this or if you have questions about this, and I'll do what I can to help you. All right, so we'll see you in class.